Good morning, and a warm welcome to you who are gathered here in Vitensenteret, and also a warm welcome to all of you joining us from the screen. Welcome to the Norwegian Cancer Society, and welcome to the Cancer Mission Hub. It's a great pleasure for me to open this seminar on artificial intelligence in cancer implementation and EU opportunities. My name is Ole Alexander Oppdalsei, and I'm the Deputy Director General of the Norwegian Cancer Society. This seminar is a joint undertaking between several of the participants in the newly established Cancer Mission Hub Norway, where we join forces to make the most out of Norway's contribution to the EU mission on cancer and Europe's Beating Cancer Plan. I will get back to this work soon, but firstly, let me give a special welcome to Professor Håvard Danielsen, whose groundbreaking research in the field of artificial intelligence is the source of inspiration for today's event. Håvard is a pioneer and a world-leading expert in digital pathology and artificial intelligence. At Oslo University Hospitals, he heads the Department of Cancer Genetics and Informatics. He managed the Do More project, a lighthouse project which was funded by the Research Council of Norway with the aim of doing more to provide faster and safer cancer prognostic. He is also this year's recipient of King Olav V Cancer Research Award. Håvard Danielsen was awarded the prize for having developed methods using artificial intelligence that give cancer patients a more precise prognosis and less overtreatment. The Norwegian Cancer Society had the pleasure, together with His Majesty the King, to hand him this prestigious award in the University's auditorium in Oslo on May the 9th this year. Today, I have the pleasure of hearing his perspective on AI-based prognosis for cancer patients, together with you in this distinguished audience of researchers, policymakers, entrepreneurs, and others engaged in the field. With this event, we aim to broaden the outlook with a cross-disciplinary approach to discuss how we achieve successful implementation of AI. We also get a look into the box of the new EU legal, political and financial instrument that are there to make us achieve the ambitious goals of the mission on cancer and the Europe's Beating Cancer Plan, where AI and data sharing play a decisive role. Europe's Beating Cancer Plan and the mission on cancer tackles the entire disease pathway: prevention, early detection, diagnosis and treatment, and quality of life of cancer patients and survivors. A total of 4 billion are earmarked for actions addressing cancer, including from the EU4Health program, Horizon Europe, and the Digital Europe program. Over the coming years, Europe is engaging in a collective effort to fight cancer, with a strong focus on research and innovation and tapping into the potential that digitalization and new technology offers. With a mission-oriented and multi-stakeholder approach, the EU aims to improve the lives of more than 3 million people affected by cancer. We have signed on this mission together: the Research Council, the Health Directorate, Oslo Cancer Cluster, SINTEF, the regional health authorities, Oslo University Hospital as a comprehensive cancer center, KS, and Innovation Norway are key players. But as we say, we are a room without walls. Ole Johan Borge, in the Research Council, described our national hub like a railway station where everybody involved in cancer meet, share knowledge, exchange ideas, and identify new opportunities and collaborate in the cancer area. Cancer is the largest research area within health research in Norway, and we have strong institutions and infrastructures within the cancer domain. We have also a strong community of small and mid-sized companies focusing on cancer. In addition, we have a long tradition for patients' involvement and citizen-centered research, which the mission invites us all to develop even further. Today, as we kick off thematic working group on AI in the Cancer Mission, our ambition is to make a solid contribution to achieving our common goal to beat cancer through European collaboration and funding. I will pass on the word to Vibeke Wallevik, Senior Principal Researcher in DNV, and member of the Kunstig intelligens in Norsk Helsetjeneste KIN-sekretariat. She is also a doctoral research fellow on AI in the health at the University of Oslo, exploring the role of synthetic data for validation of AI for healthcare. She too was a project manager for a lighthouse project, BigMed, with the aim of bringing precision medicine into clinical practice. We could not have found a more competent moderator to guide us through today's impressive list of speakers and panelists from research, health, policymakers, and industry. With this, I wish you all an insightful and impactful event that might inspire to strengthen both national and European collaboration. Vibeke, the stage is yours.
Thank you so much. That was a lovely and very long introduction. And thank you all for allowing me to be part of this initiative today. I'm very excited about it. We have been talking about AI in healthcare for a few years now. We've been talking about the hype for a long time as well, and all the potential that it has. Accelerating research, drug discovery, and handling larger data sets, and improving processes by things that we used to do manually, we can do them more efficiently now. And there are the medical devices where you can use AI-powered tools as decision support. And that's all great. We see massive investments in AI in healthcare as well. I saw someone expected it to exceed $34 billion by 2025, and that means that's a prognosis saying that all digital healthcare will have something to do with AI, almost. It's a lot. And there are quite a few AI-powered tools already on the market. Last week, FDA updated their numbers of medical devices, AI-powered medical devices, and the new number now is 521 that are approved for the US market. I've heard an estimate of 400 CE mark tools for the European market. Have not been able to verify it. Maybe someone else knows. But it should be at least up there in the numbers. There are quite a few. In the research setting, a lot is happening as well. There are developed new methods every day. We test new tools in a clinical setting. And last month, the Norwegian Research Council awarded funding to 9 research excellence centers to solve some of society's biggest challenges. And one of them is focusing solely on machine learning and AI. That's great news. Also, the Research Council of Norway is saying that almost all of their applications that come in now that have to do with ICT in healthcare, they have something with AI in it. On the other hand, though, I checked yesterday with the Directorate of Health, how many applications do we have in clinical practice today in Norway? And we counted around 10 in specialist healthcare. There are some that are being tested now in a research setting, but around 10 that are clinically implemented, and none of them are very big scale. So there's a little bit of a mismatch there. Why is that? In the BigMed project, what we did was address some of these barriers to clinical implementation, and we identified some areas that, give difficulties when you want to implement something in the clinic. And they were not only technological issues, surprise, surprise. It was legal issues, a lot around data access, culture, and competence. It was procurement and economic factors. Obviously organizational, because you need to change the way you do things if you want to get the effects. And it was a lot on infrastructure, data quality, and quality assurance and trust. So how do we know that what we implement is safe? Following Big Med, DNV, we in the research department has also done a mapping similarly around internationally with a workshop and interviews to see what other challenges. And surprisingly, not very surprisingly, we all seem to be struggling with the same things on different levels with different frame conditions, but we are all in the same boat. There are several initiatives now that have been launched to accelerate clinical implementation of AI in Norwegian healthcare. A few examples of that is the directorates have joined forces in this coordination project for AI implementation in healthcare. There is the NORA network, Norwegian Artificial Intelligence Research Consortium, that covers the academic and research perspective. And then there's KIN, that is a knowledge sharing network for AI in Norwegian healthcare, so more on the implementation and practical side. And in our discussions today, we will be digging a little bit more into these challenges. We'll look at where are we at in Norway, how can we move forward from that, how can we contribute to the EU mission. But first, before we dive into all of that and all these exciting discussions we're going to have later, we have a keynote, so let's hear it from someone who has first-hand experience in actually developing an AI tool and commercializing it so that it's ready for implementation in the clinic. And I believe Håvard Danielsen needs no further introduction. Floor is yours, Håvard.
Thank you. Good morning. It's a privilege to be here to share some of our AI research with you, and great thanks to the Cancer Society for inviting me and also for this very nice introduction. AI and deep learning represents a new era for objective diagnostics. And the ongoing digitalization in pathology opens this field to AI-based diagnostics. The field is growing exponentially. When we review the field of this deep learning studies in cancer diagnostics in 2020, so just 2 years ago, we found 1,800 publications. Last week, I did the same search and I found more than 20,000 publications. So it's an enormous growth, and also quite interesting, the mean impact of those 20,000 papers was above 5, which means that they're all published in very renowned journals, and a lot of them had very high impact. So this is really becoming a large field of cancer research. We have, over the last 7-8 years, developed a number of different algorithms based on AI. And in particular, we've been working with deep learning for the last, 7-8 years. AI is a broader definition, includes also a broader aspect of machine learning, which we've been doing for the last, for as long as we have been doing something actually. But deep learning, obviously, or convolutional neural network has sort of been a game changer for us and many others. So yeah, just what I was showing you. So this is just an example of digital pathology. It's a high-resolution image of, or a tile of a scan from prostate cancer. And as you can see, the resolution and the quality of this imaging now is as good as we are always been used to with the normal microscope. The first algorithm we developed was an algorithm to identify the tumor, so sort of to do the tumor diagnostics, to find the tumor in the pathology specimens. That turned out to be a relatively easy task, actually, as long as we had enough data. I mean, the concept of big data, as you all know, is quite important here. So we had pathologists drawing around thousands and thousands of cancers, and then we used that to train the system. So this system finds the tumor more accurately than any pathologist would be bothered to draw around it. So it's a very useful tool for us now because it allows us to automate all the other methods that we want to apply to pathology. One of these methods is an old method. It's mitotic count, which is a way to identify the proliferation rate in the tumor. This is something pathologists have been doing for the last 100 years. Quite resource demanding, and I would think also quite boring. But a good prognostic marker in several cancer types like breast cancer, malignant melanoma, and others. We have now developed an algorithm, so as others I've seen. I mean, everyone is doing everything these days, but this algorithm is now capable of counting mitosis in all solid cancers. So this is sort of a little bit of a breakthrough because it's a pan-cancer method that can now be implemented in the routine diagnostics without anyone interfering with it. When the pathologist gets the scan up on the screen, he can also get the number of mitosis up in the corner. So it's quite useful. We and many others have developed several algorithms for scoring protein expression, which is another important biomarker in cancer. And this is just an example where we have automatically scored Ki67 in mantle cell lymphoma. You can do this also with PD-L1 and all the other proteins that are in clinical use. So again, it's a very efficient way to both make more efficient pathology with less work, so we can actually do more with less work. And also it is more reproducible and actually more reliable. So we get also better prognostic data with these automated methods. Another method is DNA ploidy, something we have been using at the Radium Hospital for decades, both in diagnostics and in prognostics. It's been an important part of gynecological cancer. AI allows us now to quantify DNA in each different cell type in the tumor. So it gives us now even more precise information about how the DNA is altered in tumor cells. So, and this is a very useful clinical method. Another method based on the same type of technical or technology that we're talking about is something we have called nucleotyping. Something we also published in Lancet a few years ago. And the purpose there is to quantify how the DNA is organized or the chromatin is organized and relate that to the patient outcome. So it's another example of practical use of AI. We've been dealing a lot with prognostic markers and diagnostic markers, but AI is also very useful for simply making the workday more efficient, to be able to do more with less resources. This is classification of polyps is a project that is currently ongoing, funded by the Cancer Society, where we are taking on one of the bottlenecks of colorectal screening, which is the pathologist classification of the polyps. And just to make that story also very short, we are able to classify these into high risk and low risk. So the low risk cases do not need to go to the pathologist. We have 100% sensitivity, so we know that we're never missing any high risk, and we can reduce the workload with about 70%. So that's a sort of a very practical use of AI. Another practical use, in my institute, we're doing about 4,000 diagnosis or prognosis for patients in the clinical practice every year. And a major part of that is karyotyping, where we are looking for acquired chromosomal changes in during early or later phases of tumor. It's also a good tool to check the effect of certain treatments. And it's a very work-consuming or labor-consuming method. But since we have actually 40,000 such metaphase spread and karyotypes in our archive, we have a very good basis now for actually implement this into a fully automated AI-based karyotyping. And that will allow us to not only to reduce the labor into this, but it will also allow us to do more cells per tumor, and it will also allow us to expand to other tumor areas, which, for example, are, most solid tumors are heterogeneous. So this method is not very applicable today. But since we now can do, instead of 25 metaphases, we can do 300, 500, or however many is there, this should also be able to expand the method quite significantly. Glemte jeg å slå på klokka mi. Another method that we have developed, and which I will spend the rest of the time on, is a method which we call histotyping, where we are looking at the standard routine sections from the pathologist, the same sections that the pathologists are looking at, hemotox, lineosine, stain sections. We are using a deep learning, or several deep learning networks, to analyze these sections and to predict the outcome for the patients. A good colleague of mine, Professor David Kerr, who's a sort of key opinion leader in this field, gave me this slide because he's quite concerned that the adjuvant chemotherapy of early stage colorectal cancer causes severe toxicity for 30–40% of the patients. The toxic rate of the treatment is about 1%, and in fact it only cures between 4 and 7% of the patients. So he's very keen on getting more improved methods for stratifying patients for adjuvant chemotherapy. And this was one of the main challenges that we took on with this Lighthouse project to do more. And we used convolutional neural networks, also called deep learning. I hope you are familiar with the principles, because time do not allow me to go into detail on how these networks actually work. But in addition to the big data requirement, the most important thing with AI is the experimental design. You can train a network to do absolutely anything, and you can get very good results on almost everything. But of course, the challenge is to have some results that can be used in other labs later on and have a sort of are reproducible. And the only way to control that is through the experimental design. So that cannot be exaggerated, the importance of that. And unfortunately, among those 20,000 papers, I wouldn't say, maybe not the majority, but a very significant fraction are missing this point. And they are publishing really lovely results which can never be reproduced or even repeated if they go outside their own lab. So this is crucial. Our experimental design for this histotyping, and I'm now talking about the colorectal cancer histotype. We have one for prostate and working on one for lung as well, but I'll focus on colorectal today. Our design was based on 4,500 patients, around 60 million images altogether. 2,500 of those patients were in what we call the discovery data set, which is the data set we use to train the system and tune the system. And to train the system, we only used patients with distinct prognosis. So the patients had either died of cancer within 2.5 years, or they were disease-free 6 years or more after surgery. So very sort of clear cut, good prognosis, poor prognosis. That's the training. The rest of those cohorts we used for tuning, which is really to just decide where's the threshold between good and poor prognosis. Then we tested the system with very good results, and then there was time for the really important thing that unfortunately many are missing, which is the completely independent validation. You have to have that. That has to be patients coming from somewhere else, and it has to be new to the system. In this case, we used 1,122 patients from a trial called Quasar 2. These patients came from more than 100 different hospitals in 7 different countries, and they all consisted of either high risk stage 2 cancer or stage 3 cancer, exactly those that need a better treatment stratification. Okay. So, sorry about that. Pem? Okay, those went fast, those last 5 minutes. Okay, in that case, I'll be brief. Sorry? Well, I have some time, obviously. They will probably stop me. So the first thing we did in this networks was to, as I said, identify the tumor, which we call just segmentation. The next step is that we then tile these whole slide images, because these are big images, 5 to 10 gigabyte images, too much to put into memory when you want to have a lot of them into the memory of the computer at the same time. So we tile them up in smaller images, and at the highest resolution, it's about 6,500 images or tiles per case. And those images are all then fed into the network system that we set up. First, we used a modified version of an existing network called MobileNet. And then that went further into another called noisy and pooling to pull the data together. Yeah, I'll leave the details. And then a classification network, then that would present the score for each patient. And we did that in 10 different networks. You can't just use one network when you train, because if you do it twice, you will get sometimes slightly different results. And as you can see here, if you look at the, not sure if you can see it. Yeah, if you look at model 4, that actually has a result which is completely opposite of the others. Because this is a good prognosis patients, but that particular model actually trained it to be a poor prognosis. And this is how AI works. So that's why you have to be so careful with the design, and that's why you have to be careful with what you do. So we did 10 different networks at 2 different resolutions, and then we had 2 ensemble scores. And when those ensemble scores gave the same result, we had a distinct prognosis, either good prognosis or poor prognosis. There's a lot of shortcut that people do, but then you don't get reliable results. So we published this in Lancet in about 2.5 years ago. And this was the first time anyone published a proper study on prospective use of AI in pathology. So that had caused a lot of attention. And the results you can see here on the right. On the left, we have compared it with the pathology grading on exactly the same patients, of course. And so what we found is that we could increase the hazard ratio to close to 4, 3.84. And we actually showed then that this was the strongest prognostic marker of all the biomarkers that were used in the clinics. So it was a very good result. Very importantly, it reduced the group of uncertain classifications from the pathologist from 80% to 12%. So 88% of all the cases were given a clear, distinct, either good prognosis or poor prognosis classification. Now, how do we get this into the clinics? It's a little bit sort of abstract for clinicians and pathologists to see these scores from an AI system. So what we did then was that we trained a clinical decision support system where we also integrated the important markers in the current clinical practice, which is the TNN system. So we integrated the tumor that have the tumor growth, and we integrated the status of the lymph nodes. So those two together with our new marker was the basis for this clinical decision support system. And then we applied that results to the validation data set. Yeah, that was published in Lancet Oncology actually only a month ago or 2. So fresh results. The results now actually have a hazard ratio of 10.7. And now we're talking about when we classify patients as good prognosis, it's more than 10 times likely that that patient will survive for 5 years or more than the patient classified as poor prognosis. So now we actually have a tool that should, reliably choose which patients that should actually have treatment and which that should not. We also tested it on other material. We found an older cohort of 650 patients that never received any adjuvant treatment, which of course is, is an important side here. And as you can see, the results are very similar, which of course is not so surprising since the effect of the treatment itself is relatively limited. Anyway, so here the hazard ratio is 11.7. So this application or this algorithm is now built into an application, which is a Windows-based application that can run on a laptop as long as you have a GPU card in it. And it's one of the 400, you said, products that are CE marked in Europe. So it's ready now for the international arena. We use it in my institute. This is the report that we create. So you probably don't see the details here. But we are reporting the segmentation, and we're reporting which part of the tumor that seems to be most prognostic. We're reporting the probability or the outcome score, which in this case was 77, a poor score. And we're also reporting then the combined TNA and histotype risk score. So if you look closely at this on this survival curve on the down left there, and you take 77, you will come up to about 60% probability of survival, which is exactly the same value as we got with the clinical decision support. So it's another sort of confirmation that this is actually working. This is now also implemented in the new version of DIPS Arena, which is used by a majority of the Norwegian hospitals. So it will be available. If you look at the numbers, you will see that actually 30% of those that used to get treatment of the whole group, we will now classify as good prognosis, and we recommend not to give adjuvant treatment. If you look at the stage 3 N1 group, which is the biggest group in the middle there with 500 patients, half of those are actually good prognosis and do not require adjuvant treatment. So this is a major game shifter if we get this into the clinical use for the patients, but also for the economy of the hospitals actually, because this is quite expensive. It's around 200,000 kroner or so to do this treatment in total with everything around it. We, as I said, we have also working on prostate cancer. We haven't had time to publish this yet, so I can't give you the final results. But we tested this on a public data set from NIH, and the score itself was about 7. So it looks even more promising than colorectal cancer. We're now working also on non-small cell lung cancer, patients that have been having the tumor surgically removed. And we have only preliminary data so far, but they are going in the same direction. So since we're looking at these 3 different cancer types, which are very different. I mean, prostate cancer is something you die with. Lung cancer, unfortunately, often you die of. And colorectal cancer is like, in the middle somewhere. So very different cancer types. And if we have a method that works on all 3, it means that we have a pan-cancer method that should work on all solid cancers. So I'll conclude there. Just want to acknowledge all our collaborators. We've been receiving about 60,000 tumor samples from 11,000 patients for these 3 studies. Obviously something we could not have done on our own. So we are very grateful to all the collaborators who provide data for us. So, thank you.
Thank you so much. Thank you so much, Håvard. That was very, very interesting. Did I stay on sound or did I lose it? Oh. Sorry, technical break. So we will we'll see a very quick film, and then we'll get ready for our first panel discussion. right. So for the first panel today, I am very excited to have all these panelists that represent different parts of our healthcare community, different sectors. And I hope that can give a good sort of different perspectives on this topic. We have Hauke Bach from the University of Bergen, a professor and also researcher at the Department of Radiology. And in Haukeland, I've also heard a lot about you regarding infrastructure in radiology, so I'm very excited about that. And then we have Richard Stratford, CEO of NEC OncoImmunity. So we have this representation of industry, startups, and how actually we use AI in practice. Then we have Ishita Barua. She has done a PhD in AI in validation of a tool for colorectal prediction of, is it polyps? Yes. Ooh, great. All right. Recently joined Deloitte as well. Then we have Inga Strumke, researcher at the Norwegian AI lab at NTNU. Also part-time association at Simula. And you have a technical background, so you are one of the strong people here in that, with a PhD in particle physics, but also has been working a lot on AI and trustworthy AI, but also, yeah, how to make sure it actually works. And then we have Håvard Danielsen still with us in the panel. Thank you for that. All right, so you're all ready? Since this is quite a big panel, we have decided to skip the part where you all get to do a 5-minute introduction. We'll just jump straight to the questions, and then we'll allow you to comment. So please just let me know if you feel you want to comment on something. Also, we'll maybe allow questions from a live chat, if there are any. And if we don't have time to include those, we can still try to answer them out in writing. So please add your questions in the live chat. And to those of you in the room, you can also use that live chat. Or you can save your comments or questions for the break as well. All right. So what we want to talk about in this first little discussion, it's the significance of AI in cancer, short-term and long-term. How do we see that panning out? Maybe our medical doctor wants to go first. Ishita, do you have a comment on that? Do you see any opportunities?
I think I speak for a lot of us, not just medical doctors, but I think there are a lot of opportunities, both in diagnostics, in treatment. I think that we are seeing a lot more clinical validation studies showing effect, and there are more to come. You just mentioned in your intro that introduction, there are coming 10 more clinical studies that are planned out already in Norway, in Norwegian hospitals. I'm thinking that right now we also need to focus on how to implement those AI tools, going from clinical validation when we have the data showing evidence, clinical evidence, then we need to go from there and shift into implementation mode. How can we get the tools into the clinic? And we must remember, who is it for? These are for our patients. So we need to keep that in mind. Why are we doing this? It's not just giving into the hype of having more AI into the clinics just for the sake of it. It's for the patients. So we need to have the best tools that are validated, implemented into the treatment as well.
Thank you. Yes, anyone else see any, how do you see AI moving the field of cancer moving forward? I mean, we've heard from Håvard already, and we know what you feel about it. Richard, do you have an example of how you use AI in your job?
Yeah, sorry. From my perspective, I think AI is really key to sort of empower and enable sort of precision medicine. So matching patients to drugs, stratifying patients in a more intelligent way. But also it's actually absolutely key to actually fully, truly personalized cancer therapies in the future. So we're working, for instance, on developing personalized cancer vaccines. That is completely dependent on AI. It would be impossible to do what we do, which is to profile the tumor, identify mutations, figure out which of those make good targets for the patient's immune system, and then design that into a vaccine and do all that in a short space of time so we can treat the patient without AI. AI is absolutely key to that.
Mm. Yes, so that's actually enabling the whole...
Yeah, absolutely.
Everything you do, yeah. Inga?
So I'm a bit afraid to kind of lean out there and be a futurist in a field that I don't know very much about, which is cancer, not AI. But in general, I would like to point out kind of my favorite sentence from the keynote, which was you can train a neural network to do anything, and that's actually true. But how many of you have actually like sat down and meditated over that? You can train a neural network to do anything. Like it's true. It's called universal approximation. It's a theorem. It's proven. But like, how can that even be? Isn't that pretty amazing? Like, how many here have thought about that? Like, not the majority, right? And
For those online, that was one person raising their hand.
that was a person or two, right? But as I said, it's a theorem and we can prove it. So that means that there is this huge potential here. But we are all adults. We know there are no free lunches, right? Nothing marvelous ever comes without a price. And the price for this capacity of neural networks to approximate any function to really literally solve any problem, provided enough data, is that we often do not know what all that capacity is actually used for. And that is the reason that weird things sometimes happen. That's the reason that a machine learning system can be brilliant at recognizing street signs 1,000,000 times, and then suddenly it confuses a street sign with something that even a kid kind of wouldn't do. That's because there is so incredibly much capacity in neural networks that can learn anything. And this also means, okay, so a keyword here to Google if you want to read more about this is the curse of dimensionality. The consequence of this is that you can never test your way to complete trust. You cannot guarantee that a neural network that has learned to solve a problem will always work and function the way you expect and intended it to. We literally cannot test our way to full confidence. So what should we do instead then? That is actually an open question right now that everybody that wants to use deep learning to solve problems has to answer. And I think medicine is very well equipped to do that because you have a strong tradition for testing systematically. And you can't go and test a medicine or a vaccine on every test on the planet in order to know that it's always going to be safe. So you've developed like a systematic way of doing it. And data science.
And then, but you're saying you also need some safeguards in the system and the way you.
No, I'm saying that you need to test in a systematic and extremely clever way. Yeah. Because you can never test for anything that could happen and that could go wrong. And really the data science community doesn't have strong traditions for testing. We split our data set into 3 parts and we call them train, test, and validate. But that's not what you mean when you say clinical validation. So this is really a benefit that medicine has.
I think that's a very important point, the medical community and clinical validation, and that how we often see that when you talk between medical personnel and data scientists, you have this, yes, it's been validated, but it means two different things. So that's an important thing to be aware of. Validated doesn't mean necessarily clinically validated. You mentioned also keywording, which was provided access to data, and that's a very key question. And I saw a couple of hands here, and when you said that, maybe Hake, do you want to go first? What do you see as challenges to all of these possibilities that we see?
Yeah, so of course it's just adding to the question from right now.
Yes.
I think in the long term, it would be nice to make it possible to experience how advanced algorithms, AI algorithms actually perform on data. As you know, when you start with an algorithm and you have proven in the literature that it's useful, you still need to implement it in a specific hospital system. And that means to connect it to local data, to make it possible for physicians to test it, to experience what it does. And I think that's a very powerful model to find out what is the failure mode. If you compare this with advanced algorithms, they're called advanced algorithms. They have been in the hospital for a long time.
And just to clarify, now you're talking about not a clinical validation project set up to test it, but just to sort of to test it and to get your hands dirty and understand it, and how it works. Yeah.
So you're in the position of a clinician and you went to the conference and there's this company and they show you that this algorithm is really good. That's not sufficient. You actually have to get them into your hospital. You have to actually talk to your own people, and you have to get them onto the same table. So that means that the algorithms, they have to become what we call usually in hospitals advanced algorithms that integrate into the hospital IT. There has to be a plug and play kind of thing that you can roll them out. And there have been lots of attempts of doing this, and none of them, is like a gold standard so far. So that's one of the open things.
Yeah, that's a good point. That one thing is that it works. The other thing is that it works practically, and that you can actually move the data around in your systems and use it, as you said, plug and play. I think most clinicians that have to log on to a separate system to do something will not be motivated to do so. Richard, I thought also you had you did a little nudge when we talked about access to data.
Yeah, I mean, sorry, data is completely key actually for AI and machine learning. Without good data, you don't get anywhere. So really, you need good quality data. You need large amounts of it. It needs to be clean and well annotated, and getting hold of that is a big challenge, absolutely, in any field, I think, particularly in the biomedical field. We've early on with OnCommunity really started developing our own data sets, because actually getting hold of public data is very challenging. There's lots of bureaucracy and red tape about doing that. So we have been very proactive actually about developing collaborations and developing and generating our own data for training and controlling the quality of that and reducing the noise in that data. I think that's actually been a key part of our success.
Are there any other challenges that you encounter?
So one surprisingly big challenge is the basics. That is, for example, storage. It is trivial for somebody to just go into a shop and buy huge amount of storage. If you try to do the same into a health region, then you are spending the next 6 to 8 months with red tape. Something which...
That was quick, actually.
I know, yeah, we were lucky.
No, I mean, 6 to 8 months is quick.
Yeah.
Yeah.
Yeah, so it's, I think it's really bad that after a project, you're celebrating success as something that is trivial. Something like, oh, now we have enough storage. We spent the last 8 months trying to get it. And that's really, it's like we should focus on the patients. We should focus on solving problems instead of setting up infrastructure for the next 2 years.
So you've had the same
No, I just want to support him on this, because when through this DUMOR project, we created 2,500 terabytes of data, and that is exactly the same amount of data that Sykehuspartner is storing for Oslo University Hospital as a total. So that shows you something about the challenge. So we just wanted to start one project. We needed as much as the whole hospital had in storage space. So that's one big issue, really.
That is a big issue. So there is some investment costs here in basic infrastructure, and we need to move to a completely different level if we want the hospitals to be fully digitalized and be able to use AI. And you said you also, you recognize this challenge of going out there and wanting to procure these bits and pieces and the challenges there. Would you say, is it an organizational issue? Is it a budget issue, or what is it?
It's organizational.
Yeah.
Every time. I mean, if the organization agrees, you can always find the funding. But the organizational challenges are always the big. I mean, it's been like that since IT was first thought of in health service. And it's like that with everything, right? So, I mean, your point is absolutely correct, but it's not for AI only. I mean, whatever new method we bring into the hospital, we have exactly the same challenges, because someone else has developed it, and we might have a surgeon who wants to apply it, right? Or any other thing. So no, but that's what's good with the health service industry and the hospitals. We're used to this. I mean, we have systems to actually evaluate locally. And everyone that will start using a new application will certainly have 30, 40, or 100 patients that they followed in another project that they will test it on before they actually start using it for real patients. So I think we're quite good at that, and that was also your point. This is a very good place to apply AI.
It is. It is. Yet people are saying it's moving more slowly in the healthcare sector than others. And maybe that is because we do tend to take that time to test it. And maybe we just spend a lot of time buying the things we need.
But it's also, just to interject, sorry, it's also the fact that the requirements in the medical sector are much higher than what you're facing if you're a machine learning developer who is participating in a Kaggle competition. It's actually much more important not to show one good example as for a paper, but to be consistent is more important in this case, to show failure modes, to acknowledge that something goes wrong and not pretend that there is a score even if the algorithm is not sure about it. So I think the requirements are really different in the medical field, and that explains some of the slowness.
Which is a good thing if patients are at risk, obviously, because we need it to be safe. We talked about validation a little bit earlier. I want to go back to that. Ishita, how do you see that? How can we move forward with that? Because if we want to validate every new tool that comes in, we're going to spend 8 months buying the infrastructure we need to test it. Then we're going to apply for, the research project, and it's going to take time. How can we make that? How can we get these tools to our patients quicker?
So I don't necessarily think that the only way is to wait for tools that are validated, because we already have some, right, that are commercially available. So look to the US. They have a lot of tools that you mentioned. The FDA has already approved. Maybe some of them can be implemented also in the European market. And another thing, we need to have two thoughts at the same time. We need to be able to look for clinically validated AI tools, but also at the same time, maybe not always we need to build our own AI tools. Maybe we can buy. So if Norway is not able to, with all their resources that we have, are not able to implement, then who else is going to take a lead in that market and do so? I also want to highlight the fact that I mentioned the patients, we're doing it for them, but we also need to focus on not burdening our clinicians. The main reason why we are talking about AI is because of efficiency, where we want to make our clinicians and doctors better at their job. So it was the same thing when they introduced electronic patient journals, right? The point was to reduce the time spent in front of a computer. Actually, the time spent, less time used on just writing down notes, right? And focus more on the patient. But we've actually seen that the time used on the patient themselves, it's gone down. So we need to make sure that AI is as easy to use as, for instance, an iPhone. You don't read the manual normally. That it needs to be in the forefront when we are developing AI tools, that these are meant for efficiency, but also at the same time needs to be clinically validated. When we have that, we can actually go to our clinicians and say, hey, this is meant as a tool for you to spend more time with your patients. That's the way you're going to be able to convince clinicians that this is a good idea, because most often I talk to my peers and they're like, oh, another technological solution that is supposedly going to make my everyday life better. And I get them because I've been in their shoes. Now I'm more like a midwife trying to make AI implementation going in the right direction. But I also keep in mind that that's where the bottleneck is. They're worried that it's going to take up more of their precious time.
So the clinicians are bottlenecking the implementation if they cannot see the value in terms of...
They need to see the added clinical value. And I think that with that, you also need to keep in mind that you need to have that focus also in the medical studies for medical students that are going into a kind of different field when they are doctors, right? So these are newer times. We're probably going to use AI tools when the medical students of today are becoming doctors themselves. So they need to be equipped with that kind of technological understanding, but their domain expertise is medical sciences, right? So they need to be trained both as they are as medical doctors, but also having in mind that they will use newer tools.
And Håvard, you talked about how your results in the most basic form, you can't just present it like that you had to rework and see how do we present this to the clinicians. So there is something there. So we talked about how efficiency is the main, maybe, for some, at least in the hospital, this efficiency in doing things that are manual labor today. We have a health personnel crisis we're talking about. In some years, it's going to be not enough hands on deck. So we do need this efficiency. But Richard has told us that what they do cannot be done without AI. So it's also some things that it's enabling, right? And I heard you also, Håvard, talking about how some of these things, you can find things that you don't really do manually. How do you see that influencing the field of cancer? Does anyone have sort of any big thoughts in that long term, 20, 30 years from now?
Well, if I may, I think that the biggest challenge in that is the lack of explainability and transparency in AI. Because in order for this to really get the place that it deserves in the health service, clinicians need to understand what the systems are actually doing. And I think this is, I mean, there's a lot of research on that now. This is also our main focus for the next 4 years. And I don't think we can go around that. Because, I mean, it was okay. I mean, we could introduce penicillin without understanding how it works because it obviously saved lives right away. That's not necessarily the case applying AI. It's a more long run for many things. And so explainability, transparency, I think is the main thing that we need to.
Exactly. And Inga, you touched on that as well.
Yeah, and I just really want to say that I fully agree with this. I really think that using systems that we don't understand is a threat to human oversight, control, and autonomy. Really, I mean, I'm that crazy lady, and I really do mean it. And I see the penicillin metaphor, and I've heard it, and all this stuff about scientists don't know how the bumblebee flies, but it flies regardless, stuff like that. But drugs and animals aren't high-dimensional systems, okay? So I mean, the parallel is I don't think it's fully sufficient, especially because we want to give some kind of actorship to computer programs. Basically, is what we want to do, right? So looking at it once and saying like, oh, it looks like it's working well, just of course won't be sufficient. And I hang out at these kind of medical AI conferences quite a lot these days, and I find myself really challenged in grasping what the real problem is, because I mean the problem really ranges from this AI stuff is digital system, and digitalization hasn't come as far as we wish that it had come, to like what do deep learning models actually learn, which is a research question. So it's like the challenges are just really spanning such a huge range that it doesn't really make sense to try and address all of them at the same time.
Yes, and as I say, some things are still a research question. Some things we do know and we have and we can implement it, and then how do we do it in a safe way? That's kind of two different discussions, I guess.
Oh, it's multiple discussions.
Yeah.
But I think we have to be a little bit more open-minded than. I mean, I get where you're coming from, and of course, in theory, you're absolutely right. But medical practice is different. It's based on empirical evidence. You see that something works, and you apply it. And most of the stuff that has been the basis of medical science has not been understood at the time that it started saving people's life. That's not a reason not to try to get it and not try to understand it, but to say that if you have a good method, you shouldn't apply it until you're fully aware of all that's going on. I wouldn't agree with that. That would put us back 30 years.
I mean, there's a huge ethical trade-off here. It's between misuse, potential misuse, I mean, by just a computer program, if that makes sense to you, and misuse, so not using something that could potentially save lives. And I'm so happy. I'm an AI researcher. I'm a particle physicist. I don't have to decide in this trade-off, but it's a huge trade-off. And it's really one of these, I think, the main ethical challenges that this technology is right now forcing us to basically solve.
Okay.
Yeah, just to now talk about something completely different. I really like the question 20, 30 years in the future, and will we use AI? I would also like to ask who is going to use the AI. So there's this one big thing on the horizon that large international companies would like to get access to health data. And with access to large amounts with AI, the hope is that they could do much more than, for example, a hospital can do. So the question is a little bit, in 30 years, will there be hospitals? Will we just look at our cell phones and with diagnosis everything that we are doing? So it's a little bit weird to think about this. But one of the challenges that we see in the Western Norway health region is that we have to become bigger. If radiologist wants to introduce an AI tool, they cannot do it in their institution. The leadership will ask you, do you have to go together with another hospital? You have to do this in consent across institutional borders. So we are lucky that anything that we do implement is in kind of the health region, but we have to extend that reach nationally and internationally. The domain of radiology has to be big enough to compete with Google. That's kind of, in 30 years, probably one of the things we look at. Sorry.
And what you are talking about now is this complete revolution, right? Where you get these benefits because you actually organize yourself differently or you do things differently. Whereas maybe sometimes, and particularly now in the beginning when it's still quite new, our way of safeguarding when we implement new things is we kind of maybe we do a double, so we do manual and we do use the tool, and we have some of these. So it's going to be an investment cost in the beginning. But do you see this, do you share this vision, or do you think we'll be able to actually really revolutionize the way we do things with this new technology?
I'm optimistic, really. I think, I think AI is going to lead to earlier diagnosis of patients, and it's going to make sure in the future that the right patient gets the right drug at the right time. And I think that's going to really save a lot of lives. So I'm an optimist.
That's good. We have some optimism.
Well, I mean, we're already doing it, aren't we?
Yeah.
The main change in the strategy for Oslo University Hospital for the coming year, related to budgets and everything else, is home hospital. I mean, we try to get more and more patients treated at home. So, I mean, and of course we couldn't have done that if we didn't have a lot of the technology in place already. And obviously AI will enforce that route. There's no question about that. So I think we're on that way. But we can never replace, sympathy and compassion and warm hands. So I don't believe that there's either Google or yourself kind of health system in the future.
Do you still believe in the future of hospitals?
Absolutely.
Physical hospitals?
Yes,
yeah.
that too.
Okay.
But I still believe in people have to be involved.
Yeah.
That's the main thing.
Because there are many ways of implementing a tool and into your process. And we did talk about the clinical benefits we started out with, or the clinical effects. And as long as we see those, then hopefully we'll be able to procure the storage we need and get moving forward. With that, I think we'll sum up this very, very lovely discussion. Thank you for all your viewpoints and your input. Thank you very much. An applause.
Too often, cancer cuts life short and shatters families. Especially when cancer hits children, it can affect them for the rest of their lives. Almost 4 million Europeans per year are diagnosed with cancer. This disease still kills 1.2 million people per year. But there is good news. Screening, diagnosis, treatment and survival rates are improving all the time. But we still need to do more together. Together, we have to improve prevention. Together, we have to care for all. Together we can save lives with more and better research and innovation. The European Commission has set up a board of top scientists, clinicians and patient representatives to advise on how best to do this. Because we all have experience of cancer, either directly or through loved ones, friends and colleagues. And because we are in Europe. Let's work on this mission to fight cancer together. Tell us your concerns, what needs to improve. Let's share this journey together.
We are very honored to have not one, but two speakers representing the EU perspective on AI in cancer. Firstly, we will hear from Evangelia Markidou, Head of Sector of AI Technology Deployment and Impact at DG Connect. She will give us first this overall view of AI policy from EU, implementation and consequences of the AI Act within health and care context, and how this AI Act will support research and innovation in Europe and bring us competitive advantage. That's going to be very exciting. After that, we will hear from Alexandra Veselovska, who is Policy Officer in the section on e-health, well-being, and aging at DG Connect. She will elaborate more on the role of AI and data to achieve this cancer mission objectives and tell us more about relevant EU initiatives across EU4Health, Digital, and Horizon Europe programs. So ladies, you have 20 minutes between you, as I have been told. First of all, let's hear from Evangelia. Floor is yours.
So, my name is Evangelia Markidou, and together with Alexandra, we're going to present you a few things today. For me personally, I would like to present an overview of the European approach on AI. And basically, we are two units that are dealing with this aspect. How we are dealing with the European approach on AI is we're dealing first with the ecosystem of trust. This is the sister unit in Brussels that also published last year the draft AI Act. And then there is the ecosystem of excellence to put everything in place and implement all these actions. And these are being done in two units in the Commission. And basically, as I said last year, we published the draft AI Act. Why the draft AI Act? That while we know for how many things AI can be used beneficially, also AI can be used in a not so nice way and can also be abused, and therefore we have to make sure that consumers are safe and their fundamental rights are respected as well. So the draft AI Act is basically a risk-based approach. It has, as I said, this risk-based horizontal legislation that defines the boundaries on what use cases of AI systems are allowed and under what conditions they are allowed on the EU market. Well, it also introduces the kind of AI-targeted requirements for systems that are defined as being high risk, primarily when it comes to data quality, transparency, and human oversight. This was also discussed in the panel before us. It is also important that it makes healthcare solutions more safe, reliable, and trustworthy for healthcare professionals and patients, and to ensure that it integrates existing sectorial frameworks in AI, in health, for example, when it comes to medical devices, by relying really on their kind of sectorial conformity assessments, the certification bodies, and the surveillance systems. And it clearly identifies this risk-based approach, what are considered the unacceptable risks. So AI systems that are a clear threat to the safety, livelihoods, and the rights of other people, those will be banned from the EU. And this will also include AI applications and systems that manipulate human behavior to circumvent also the user's free will. For example, there are toys that are used as voice assistants to encourage dangerous behaviors of minors. So child protection is an issue here. So, and also social scoring. These are by some governments, these kind of AI applications will be considered unacceptable risks. Now, there is also the high risks that we believe that a majority of the health devices or applications around AI will be related to. So, I mean, there we have to make sure that AI applications are being safe and the safety components are regulated of those products. The next slide. So the high-risk AI systems, they will be subject to strict obligations before they can be put on the market. So there will be the adequate risk assessment and mitigation systems will have to be put in place. High quality of the data sets that will feed into the systems have to be checked, and in order to minimize risks and discriminatory outcomes. There will be the logging of activity to ensure the traceability of the results. the detailed documentation, providing all the information necessary on the system and its purpose for authorities to assess its compliance, and a clear and adequate information to the user, whichever user it will be, even also to end users, and to make sure that there is an appropriate also human oversight in order to measure really the risks and to minimize the risks. And of course, what is very important is really a high level of robustness, security, and accuracy of those systems in order to be able to reach and being used in the EU market. In particular, when it comes to, biometric identifications, they're also considered high risk, and they are also subject to strict requirements. And these are aspects that authorization to use of those will be probably subject to a judicial or other independent body that will give the appropriate kind of conditions to be used. But in any case, we believe that when it comes to health, the majority of the systems will be either high risk or a limited risk. And when it comes to limited risk, we consider AI systems with specific transparency obligations, where, for example, when we have a chatbot, that users are aware that they are interacting with the machine, so they can take also an informed decision to continue or step back. And of course, going back to this pyramid, for minimal risks, the legal proposal allows the free use of those applications, such, for example, AI-enabled video games or spam filters. And we see also that the majority of the AI systems, they will fall into this category. Of course, when it comes to healthcare, we believe, as I said, that they will mostly fall in the category of high risk and transparency risk. In terms of governance, the Commission proposes that national competent market surveillance authorities will supervise those new rules once they will enter into force, and we believe this will happen hopefully at the beginning of 2024. And while the creation of a European artificial intelligence board that will also be created will facilitate also the implementation, as well will drive also the development of standards for AI. Additionally, what we will foresee, and that has to be discussed and decided also at the moment with the Council and the European Parliament, are voluntary codes of conduct proposed for non-high risk AI, as well as regulatory sandboxes that will have to be put in place on time for and before the AI Act will enter into force, in order to facilitate also the responsible innovation. So in a nutshell, the proposed AI regulation wants to make healthcare solutions safer, reliable, and trustworthy, both for the professionals that are going to use the tools, but also for the patients. It also aims to facilitate the uptake of high-risk solutions, and as I said, only limited obligations will be placed on the users and the healthcare professionals, but the regulation ideally will put everything into place. It introduces AI-targeted requirements, notably, as I said in the previous slide, on data quality, transparency, and human oversight, and wants to also smoothly integrate existing sectoral frameworks in health, for example, as it is for medical devices, in order to rely on existing conformity assessment, certification bodies, and surveillance systems, and ensure that existing sectorial bodies are involved in the discussions and all the initiatives that we will put in place. All of that is happening in the sister unit, in the unit that I'm representing today. And this is one other example of what has been published last year, is the Coordinated Plan on AI. We try to make sure that we bring excellence, research excellence from the lab to the market. And for that, we have several instruments put in place. And of course, one of the strategic sectors that we have targeted in the Coordinated Plan is health. And to show you a few examples, the ecosystem of excellence, we have the public-private partnership on AI, data, and robotics. We have put in place across member states the European Digital Innovation Hubs. The majority of them have a focus on AI, several of them also on healthcare. We have very important, the testing and experimentation facilities that we fund under the Digital Europe program, where Norway also participates. And one of the 4 testing and experimentation facilities has a focus on healthcare, and they will start on the 1st January 2023. We have the AI on demand platform. It's a very important tool. I'll also have a slide later. And of course, we have the networks of excellence centers that really try to push the limit where it comes to AI and really progress when it comes to AI excellence. All of that is building the AI excellence of the ecosystem of excellence. The PPP is quite important because we try to pull together all the resources on one hand and try to make sure that this European public-private partnership really kind of can represent not only industry, but also public stakeholders across Europe in order to therefore mobilize the community, but also define research priorities, but also have a stronger voice when it comes to standardization bodies and really moving standards around AI the way, in line with the European approach on AI. And of course, this public-private partnership also puts the strategic research priorities that are then funded primarily under the Horizon Europe program. The European AI on Demand platform, as I said, wants to bring also everybody together, researchers, but also public stakeholders and industry. This platform is funded both by the Horizon Europe and the Digital Europe program, and it really aims to ensure really that researchers, but also public stakeholders and SMEs and industry can find reliable AI resources on the platform and reuse them. There is also going to be a marketplace that will be put in place under the Digital Europe program, where probably users can also put their resources available, make them available, but also can sell those resources. As I said, it will also allow for an experiments platform on the system. And something that was also discussed in the previous session is what we try to use to do also under the Digital Europe program to ensure that the data and the computing resources, that the whole infrastructure is available in Europe in line with the European kind of legislation. As you all probably know, there's also a draft Data Governance Act in place. So it's all around data, and it's all around quality, and it's all around being able to access the necessary computing infrastructures when you need them, whether they're on HPC, whether they're on the cloud or on edge. And I think edge is something that is also kind of upcoming when it comes in the healthcare area. The testing and experimentation facilities, in short, they're really an important tool here when it comes also to the European AI approach on AI, because we really want to test mature technology, but we also like to test the robustness of those technologies, because they have to be ready and to be put on the market. And of course, those technologies have to be in line also with the AI Act. So some of those testing and experimentation facilities that we'll put in place will also act as the regulatory sandboxes in the respective member state. And I think that was it. So coming back to that, when it comes to the requirements for the AI high-risk data, what we're doing in the unit makes sure that, also under Horizon Europe, also with the unit involved in data, is to ensure that we use high-quality data, that the data is unbiased, it's clean. Ensure that any kind of research that is funded also under the Horizon Europe program really kind of focuses on a transparent, robust, explainable AI. It's very important. Human oversight is very important. We also will focus in this year's call on collaborative intelligence, because we believe that this is the way at the moment to move ahead and really kind of improve healthcare applications also around AI. The collaborative approach. And of course, a lot of our projects and also the future projects really focus on the robustness of those systems, the accuracy, transparency, but also cybersecurity, because it's very important that those systems, wherever they are being put in place, are really safe from external kind of factors. I think that would be it in a nutshell, because I'd really tried to limit it in 10 minutes. So thanks from my side. Over to you, Alexandra.
Thank you so much, Evangelia, and please stay on in case there are any questions that pop in later on. Alexandra, the screen is yours.
Yes, hello. Can you see me? Can you see my slides?
Yes, we can.
Yes, okay, so welcome. My name is Alexandra Wesolowska, and I work as a program policy officer in DG Connect in yet another unit than Evangelia, and not the second one that she mentioned. Our unit deals with digital health, and my presentation today focuses on the role of AI and data to achieve the objectives of the European Cancer Strategy. And in this context, then I would present a few initiatives and actions that are funded from the various programs. EU programs. Yes, so as was said before, I think I do not need to repeat too much. Digital technologies and AI technologies play an important and an ever increasing role in the battle against cancer, and they show value across the whole care pathway, from the prevention in early detection and diagnosis of cancer, then in treatment and care, and then in monitoring and increasing the quality of life of cancer patients. And artificial intelligence solutions offer a paradigm shift towards data-driven decision-making in medical care. And it is expected, it was said already in the panel before, that these technologies will strongly contribute to tackling cancer, as they will be supporting physicians in clinical decision making and treatment. So the Commission has supported over the past years a number of actions on to facilitate the development of artificial intelligence technologies in healthcare. And now we have launched, and we will be launching soon, a number of actions relating to data and AI in the context of the Cancer Mission and the Europe's Beating Cancer Plan. Just to remind briefly about the objectives of the mission on cancer, and the goal is to, jointly with the Europe's Beating Cancer Plan, improve the lives of more than 3 million people by 2030 through prevention, cure, and for those who are affected by cancer and their families to live longer and better. And I just to briefly say how far have we gotten with the implementation of the cancer plan, and especially I want to focus here on the AI and data dimension of these actions. So 9 topics have been published so far, and we already see that some project proposals submitted, for instance, to the screening topic or to the understanding topic, which are currently undergoing grant preparation, they will use AI technologies. They propose this, and they have huge cohorts, and they want to use AI for some of the project work. They integrate different data types and sources, genetic and non-genetic information. They develop novel, cost-effective technologies and strategies towards prediction and early stage detection of different types of cancer. So we see that that AI technologies and technologies based on data, on large amounts of data, are so present in cancer research that even if the calls of the Cancer Mission are not focused specifically on the AI, such technologies, the AI is proposed, AI approaches are proposed, and then can be funded. So of relevance here is also the coordination and support action that has started to prepare the UNCAN initiative, UNCAN EU initiative. So this work has started now in September with a coordination and support action. The project has a duration of 15 months, and it will prepare a blueprint of this UNCAN initiative. And the idea here is to share reliable, high-quality cancer research data from various sources and integrate them at an unprecedented scale within a federated cancer research data hub. So I think this is certainly an important initiative to follow. Also, what I want to say here, that there are other parts of the Horizon Europe program in the health cluster, or in the digital industry and space cluster, or in the research infrastructure part of the Horizon Europe program, where projects focusing on cancer, or ones that have a cancer use case, are proposed and are funded, and they will also contribute to the Cancer Mission objectives. So as long as cancer is not explicitly excluded, such projects can be submitted to those calls. Now, the Cancer Mission supports the Europe's Beating Cancer Plan, which the objectives of both initiatives are aligned, and they should be considered jointly as an EC strategy on cancer. So while the Cancer Mission is about research and innovation, Cancer Plan is a true cross-policy approach to fighting cancer, and there are 10 flagship initiatives and 32 actions which cover different across different policy areas. And I would then want to focus on a few of them. So firstly, this is the initiative that we are responsible for in this unit where I come from. So and this is one of the flagships of the Europe's Beating Cancer Plan, the European Cancer Imaging Initiatives. And this initiative will support the development of new computer-aided tools based on AI technologies to improve personalized medicine and innovative solutions in cancer care. The cornerstone of this initiative will be the Federated Infrastructure for Cancer Images Data, a federated European infrastructure for cancer images data that will be created with the support of a project funded under the digital program. And this project is currently undergoing grant agreement preparation and should start in January. The infrastructure will build on the work of the cluster of 5 projects that we are currently supporting from the research program and that you may know. But the new project will involve also the relevant European research infrastructures, clinical centers across Europe, and repositories of cancer images. And it is very important that this infrastructure will be open to engagement of new stakeholders, both on the provider side and the users, because the ambition is to create a European infrastructure which will address the issue of data availability for developing AI, which is representative and not biased, so on. So the project will make anonymized cancer data available to researchers and innovators, also innovators, and it will provide an experimentation platform for development and benchmarking of AI tools towards precision medicine. And within this cancer imaging initiative, then, we want to link these cancer images to the high performance computing capacities and also involve the AI testing and experimentation facilities that Evangelia mentioned. And then so that the innovators then can test their solutions and technologies in close to real life conditions and get other support. And finally, there would be the European digital innovation hubs that will be used to support the rollout of the technologies. And then they will be the first point of contact for the innovators, the SMEs, where they can learn about the legal requirements and testing for their tools. Another initiative action that you may be familiar with of the Europe's Beating Cancer Plan is the 1+ Million Genomes initiative, which aims to enable secure access to genomics data and corresponding clinical data across Europe for better research, personalized healthcare, and health policy making. This is also an initiative that we run here in the unit where I work. And since the Digital Day in 2018, 24 countries, including Norway, have signed a declaration to step up efforts towards creating this European data infrastructure for genomic data. This work is supported, this initiative is supported by the Beyond 1 Million Genomes project, a coordination and support action, which has been engaging with various stakeholder groups and experts. One part of the collaboration is the Genome of Europe project, multi-country project that works, that aims to build a European network of national genomic reference cohorts representative of the European population. What is important here is that in the next phase, we are approaching the next phase of this endeavor. So now in November, a project funded under the Digital Europe program will start, a project which is a bit like the images infrastructure. It's the Federated European Infrastructure for Genomics Data. And that will the project will establish this infrastructure, enabling distributed learning for various use cases, and one of the use cases is cancer, and provide a data access governance and a sustainable coordination mechanism. So as I said, this project is now in the final stages of the grant agreement preparation and should start in November. And finally, this is my last slide. Of course, you are familiar with the Commission's proposal on the European health data space. And this is also one of the actions in the Europe's Beating Cancer plan. This proposal has been adopted by the Commission in May and is currently in the co-legislative process. Here, the overall objective is to ensure effective use of health data, both in the better exchange and access to different types of health data, both in the primary use context, so for the healthcare delivery, and for secondary use, including research, innovation. And in terms of infrastructure, this proposal proposes to establish a new cross-border infrastructure health data at EU and secure environments where health data will be processed. So while this regulation is still in the co-legislative procedure, the preparatory work on the infrastructure has started with the EHDS2, we call it pilot project, supported from the EU4Health program, which will then explore possible solutions for the infrastructure for secondary use and test these solutions in a real life setting. And here also one of the use cases likely will be on cancer. So this is led. This is a consortium of 16 partners led by the Paris-based Health Data Hub, and I believe the Norwegian Directorate of eHealth is a partner in this project, which will allow Norway to be closely involved. So this, I think, is also an important initiative and project in this context. So here, with this, I finish my presentation. Back to you, please.
Thank you so much, Alexandra and Evangelia. I don't know about the rest of you, but I am blown away by the amount of information we just received. And thank God I have someone to help me sort through all these thoughts. Let's welcome the next panel, number 2, for our next panel discussion on stage. And please, Evangelia and Alexandra, if you stay online, in case there are any questions that pop up for you, that would be great. So welcome to our second panel of the day. I'm very glad you are here to help me sort through this topic. We have Ole Johan Borge from, he's the Department Director Health of the Research Council of Norway. So representing the research funding. Then we have Helga Brøgger. She's a medical doctor and also works at the Norwegian Board of Health Supervision, so in a way representing our authorities. Then we have academia. Bjørn Hoffmann from the, he's a professor at the Center for Medical Ethics at the University of Oslo. And then we have Kjetil Widerberg, who's general manager of Oslo Cancer Cluster, in a way representing industry. So we have all these great perspectives. And the main topic that we have been given for discussion here today is to reflect on how Norway can best contribute to the EU missions on EU cancer mission and with the AI perspective. Does anyone want to go first and have an overview? I can see Kjetil is already twitching.
I'm very happy to. So thanks for being here. I think we have very good input for the previous panel and also for EU. As I say, I can here take the role of representing the industry. I also represent the universities and research institutes in Oslo Cancer Cluster. But if you look at AI in health, from difference to many disciplines, and I may offend someone here, but often the cutting edge of innovation in artificial intelligence is not happening in academia. It's happening in companies. And that's an interesting aspect. There are some very powerful companies that exist with the most amount of data and also the most advanced science. And right today, if you look at what's happening in EU, in artificial intelligence, I think Håvard showed us that there's a lot of new articles coming in his area, right? tenfold, I think, for the last couple of years. But still, the most innovation in artificial intelligence is happening on looking at pictures of cats and dogs. And that's to reflect on, because I think that it's a fundamental thing that if we're going to make this happen, we need data access. And I'm very happy to see all the initiatives that EU is doing in this. I'm also afraid of how big these efforts will be and how fast they move, and also how a country like Norway could contribute. And this was a long introduction to your question. So how can Norway contribute? We have some representatives here today. In Norway, we have public health systems. It's one of the best in the world. And we have a cancer register that has collected data from patients, and are still doing that every day for the last 70 years. This enables us a possibility to see what happens on a population scale, longitudinal, that most other countries cannot do. And this can both help us to understand what's happening with patients and cancer, but also help us to document what works and what doesn't work, and develop medicines, document the effect of interventions faster.
Thank you. Ulian, you had a comment or another answer?
Well, I would like to start with describing a little bit the current situation. And because the reason why I want to do that is because the current situation is very good. There are too many researchers in Norway believing that applying the European community for funds is very hard. I'm going to show you a few numbers. Since 21, within the Horizon Europe program, there has been 45 calls within the health space. Norwegian organizations applied on 75% of these calls, meaning that Norwegian researchers were applying almost everywhere we see fit. Of those calls, we were participating, or Norwegian partners were participating with one or more member in 14% of all applications. That's a lot. But even more impressive, when you look at the applications that earn money, we were participating in 23%, meaning that the applications Norwegian researchers were participating in succeeded with a much higher likelihood of success. And the overall success rate for Norwegian researchers within this domain is 30%. That's 5 times almost as the highest success rate compared to the same researchers applying to the research from the Foundation of Norway. And when you look at numbers, we have, if you look specifically on cancer and artificial intelligence, during the last 2 years, we have earned, or being a part of, and Norwegian researchers, they have received 10 million euros on cancer and eye. That's very, very good. That was my comment.
That's a very positive starting point. Helga, you wanted to?
Yes, I would also like to follow up on the positive side, because there have been a lot of mention of the obstacles and the red tape. And of course, there is a lot of red tape and obstacles. And there's nothing that we can do right now, especially not the Norwegian Board of Health Supervision with the legal requirements. They're there by law. But what we can do and are doing is guide. And we have a quite unique group in Norway. It's a multi-agency guidance service that we provide, both public and privately funded projects on the regulatory pain points, both on the MDR, on the medical device regulative, but also on the different acts that pertain to the health sector. And it's a group of the Director of the Health, Norwegian Board of Health Supervision, the Medicine Agency, and e-health. So it's sort of all things covered. So just make a case for that. So not all things are perceived as obstacles or stumbling stones. Maybe they can also be seen as guidance. Thank you.
Yes, because there are a lot of also new laws and regulations that will even complicate this picture further. So you're saying that you are ready to help whoever needs that help. It's a very good pitch. Okay. And Björn, how do you see us positioning, or what can we contribute with in EU in this cancer mission? How can we help?
I'm a simple academic, so I have simple answers. And my answer is we can foster trust and trustworthiness. And I think we can do so in 3 different ways. I mean, we have excellent health registers, so our data are trustworthy. So contributing by that is very important. So we avoid the garbage in, garbage out problem. But as I think Håvard and Donaldson pointed out, even if you have gold in, you can have thrash out. So what we have to do in addition to that is to validate properly, and not only showing efficacy, but also showing effectiveness and eventually efficiency. So in validating what we do in a proper way, I think we can contribute significantly. And secondly, we have a tradition in Norway of taking into account privacy issues and also confidentiality. We've been accused of being quite strict, but I think it will pay off in the end. And as we have seen by the presentation so far, cyber security and safety is important. So I think we also can contribute on that point. And the third issue where I think it's very important that we actually do contribute is with regards to accountability and responsibility, because some of the AI systems may have outcomes that somebody has to take responsibility for, and we have to be upfront in doing so, and I think we have a good tradition for actually doing so.
So you're saying the Norwegian traditions are trust and transparency, a tradition for privacy, which we have had for a long time in the healthcare sector, legally as well. Data access, you talked about cancer registry or the registries, and accountability.
Exactly.
Very good points. Yes, Johan, you wanted to add to that?
I could, but before that, I would like, if we have our 2 European colleagues still with us, are they still here?
We believe so. So
There-
ask your question. And,
Good,
and,
because I want to make sure that you know, or they know, that health is by far the largest research area in Norway, and cancer within health is the largest topic within health research. And we have all the long traditions, and I would like to ask, the question I would like to ask is that how, from your perspective, should we organize ourselves? Should we do something to be the best possible match to the calls and the different areas and topics that are going on? How can we contribute? Because I think what we have in Norway these days is that we have this Cancer Mission Hub, which is a perfect place where we all meet, both from the company, from the government, from the science, from the patient groups. I mean, the entire ecosystem, we meet in one place every week. So back to Europe then.
Just to be precise, should we ask Alexandra first, or who talked about the funding initiatives?
They could jump in after I think.
Okay. Who wants to go?
I could go first.
Okay.
It's Alexandra. I don't know if you can see. So, yes, so we do know partly of that Norway is very advanced in the cancer research, and the numbers that were quoted show that. I didn't go in that detail analyzing the numbers, but indeed they prove this. The Norwegian Cancer Register, very valuable resource, and the traditions you mentioned, and also the Norwegian experience in sharing the data across borders. You have the Scandinavian network, the Nordic collaboration on data resources. So this is remarkable, and we have heard that data is the key resource to develop AI technologies, and data sharing across borders will be key. So I think what certainly Norway can contribute is to share this experience both to the other countries and within the expert groups and the member state groups, the subgroup on cancer where member states are involved, to convince the others to as far as they can, based on the legal rules, and to follow that path. And for the participation in the projects, you are already doing quite well. But now, when I listen to the previous presentation, I had this thought that we know where the challenges are. reaching the whole path, both with validation, with testing, with getting the tools to the hospitals. And you say that Cancer Mission in Norway is the hub is well placed because you gather all the stakeholders. So try to present this, transmit it in the context of a European project to make a convincing case that you address the whole path. So I think that would be brilliant for the Cancer Mission.
Thank you so much. Evangelia, do you have anything to add to that we try to present this, that we have the whole path from bench to bedside or through validation and implementation?
I think, I mean, for me, I mean, Norway is, when it comes to Horizon and Digital Europe, is like the same, I mean, has the same kind of, I would say, possibilities and rights as a member state. So, I mean, they participate in all the aspects. And Norway was also participated when we discussed the coordinated plan on AI. And there are joint actions, what has to be done at the member state level, what has to be done at the national level, regional level, or also the European level. I think the funding opportunities are there for everybody, and Norway is very prominent in the majority of research. That was also said previously. I think it's important when it comes to healthcare really to collaborate together, because I think the pandemic showed that when we really work together on a common kind of goal, we really achieve a lot. So I think the possibilities are there to collaborate together. And one possibility also where Norwegian participants can have a bigger role also is the public-private partnership I mentioned earlier on AI, data, and robotics. So by joining that, Norwegian partners have also a bigger role in saying, I mean, and also kind of have a bigger role when it comes to standardization, but also the research where research should focus. That I would say would be my bit on the question.
I think you said public-private partnerships, and Kjetil woke up.
I wasn't full asleep, but no, I think it's a good point. I wanted to Alexandra also to address this, because if you look at some of the big projects on the image bank and health data space, they are following regulations from the large countries to implement it scale in EU, and that's very important. But when you come to what we have in the cancer registers or in the health system in Norway and the Nordics, we can do things we cannot do in the rest of Europe. So you can think about it as like a test bed for some that could be implemented in all of EU. Is that something that are, what should I say, can be used into a cancer mission, or would it be one for all, so to speak?
I mean, this is certainly something great that you can do this, and this. I don't have an immediate answer to this, but within the Cancer Imaging Initiative, there will be opportunities to be engaged in that initiative, in that federated infrastructure, which will offer, as I said, this platform for testing, for developing AI solutions. There were, well, the project is not yet there, so I cannot say too much, but there will be different ways of contributing, and perhaps this testing, what you can do with your within your environment, could be there as well. This I cannot really say now, but what I would invite you to do is to follow this closely. The Cancer Imaging Initiative will have a website soon, and there will be a launch event early next year. And as I said, there will be opportunities to get engaged in that initiative. The details will be known once the project starts. And there, you know, I think just, you know, get in touch with the coordinator, ask what would be, and I think we all want this to work, and I'm sure you will find a way to contribute.
Thank you. Helga, you have...
I would like to address the issue of how well people are familiar with the healthcare sector, and not only the rules and regulations, but also culture and trust issues. It's a complicated and wonderful field. It's the best place to work. But there are a lot of new players that needs to be told of the uniqueness of, and not just perceive the regulations, which I'm, of course, really important for me, as obstacles. There are pathways through this, and it enhances and ensures that their products can be delivered to the healthcare market. So they had to know which regulations to oblige to and how the pipelines to go through when they have a good idea and funding, and hopefully also easy access to data. They have to guide them, and they have to have some place to learn. I don't know where, but I think it can enhance the process and speed up if they know this early on.
Exactly, and we talked about in the previous discussion how we need to educate our healthcare personnel in digitalization, but equally on the other side, we need to also educate anyone who comes up with digital solutions and the data scientists on how the healthcare system works, how the regulation works, and how to move through that maze, which we can call it. Johan.
I think this, what you just said, is the main reason why I think the Cancer Mission Hub is such an important structure. And the reason for that is that the solution might be simple, but how to adopt it, extremely complex. And that means that that complexity, we need that when we do all the research, all the innovation. We need all the partners. We need the ethical discussions. We need the governmental instructions on how to find a way through the hurdles. We need the companies. We need the patient organization, and of course the researchers. And that is, to some extent, something different, because if you go 10 years back, then you could be a single researcher matching up with a few colleagues throughout Europe and sending an application. These days, that is not possible. You need to have all these partners within the same project, and thereby also increasing the likelihood both of success and, of course, then implementation and patient need in the end. And I could follow up, because we see in our data too few patient or end users, and we see too few companies. So if you could do even better on those two aspects, we would probably succeed even better.
Just so we don't stand here and all agree to everything. So it's a different theme, Orion. It's not to your point, but Evangelia, you put up the pyramid of risk in AI, and on the high risk, it was put up manipulation. And I'm just curious now. So if you recall the Cambridge Analytica scandal, where they used Facebook to manipulate for political voting, there's also been a fair amount of publications on how you can use nudging for behavior, for social benefit. So would this be excluded or not?
So, as you probably know, I mean, or I don't know if you had a look at the draft regulation, but it works a lot with use cases. So once something is happening, then, and we know that this could pose a risk, we will include it as one of the use cases. So nudging per se, not, but I mean, these are also aspects that we have to deal with from the other side. So it's a lot about awareness raising and making people aware how our system works. So this is something where I think explainability also plays a role. But in any case, I think it is important when you're using any kind of system that is based on or that has AI behind, that users are aware of what can happen and how the information is being produced and everything. So per se, as I said, the Draft AI Act, it works with the use cases, with the known use cases, and we never know what will happen in the future. But in any case, there are aspects that we have to take into account. But we really want to ensure that we will have trustworthy AI available in Europe, and for that we have to kind of see how to best address this.
So that means if somebody finds an algorithm for helping Facebook users smoke less or train more, that could potentially be applied to the market?
Yeah, then it has to go through the whole procedure. So we have to see which kind of category it will fall into. And then, of course, what the implications are. If it has to go to conformity assessment, has to be tested, has to be, validated. So all these aspects have to do with where exactly in this pyramid it will fall up to. And then, of course, also what the users are, I mean, the end users, etc. But it really depends on the actual, also the data that it will have access to and what it will do and the explainability. I mean, such algorithms have to be able to be transparent so we understand what is actually happening.
So if it's an informed nudging, then maybe there's been...
There's hope there, I hear. It's not excluded automatically when it's informed nudging. That's good.
Very good.
I don't have the full list of the use cases, but I mean, I can see with the colleagues in Brussels.
Thank you.
Thank you. That was a fun question, Kjetil. Also, another question that has come into our EC representatives is we have these Norwegian initiatives that I introduced earlier, KIN Nora Network and this coordination project examples. Are there any similar EU initiatives that we should know of? So groups to share competence and experiences and knowledge sharing networks, both for research and for implementation practice. Is there anything you are aware of?
Well, I'm sure there are such things, such networks. We come from DG Connect, and then there is DG Santé and DG RTD that are in charge of the health file and the cancer mission. So, I think what I know, what I meant with the sharing experiences, this was more on the within the member state group. There is a subgroup on cancer. This is related to the cancer mission itself. So there you talk with the other member states. Also, what we know, there are working groups and expert groups within the 1+ million genomes initiative. And I have heard from my colleague that Norwegian experts are already contributing to the working of that groups, for instance, on the Genome of Europe working group. So certainly there, this is exchange of experiences. I'm sure within the cancer imaging initiative, a similar structure will be proposed, but for the groups, specifically for the cancer mission, there must be some, but then I would need to check with my colleagues in DG RTD.
Thank you so much. We can follow up on that afterwards. So to summarize what we have been discussing, I see you're quite positive and there are many opportunities, and we've highlighted some of the particular Norwegian areas around transparency, how we can use this ethics background that we feel are embedded in how we do things as a positive way. A lot going on, more of the public-private partnerships and end users. And very excited to see where we're going from here. Thank you so much to the panel. Thank you to our EC representatives that have joined us from afar. Thank you so much. All right.